Jai Jirendra, Namaste and welcome to my channel. Today we are going to solve the 81st question of the problem solving series and the 6th question of the topic linked list. The difficulty level for this question is easy and this question has been asked in Google, Amazon, Microsoft, Meta, Oracle and many other companies. Linked list cycle. So we are given a head of the linked list and we need to determine whether in this linked list is there any cycle or not. Okay. So with cycle we mean that here in this first example, when this 4 is pointing to 1, 1 pointing to 2, 2 pointing to 3, and then 3 again pointing to 1. So this 1, 2, 3, this is forming a cycle. Since this has a cycle, so we will return true. Okay. Here in this second example, 1 is pointing to 2, 2 is pointing to 1. Again 1 is pointing to 2, 2 is pointing to 1. So there is a cycle. So this also has a cycle. So we return true. But here in this example, 4 is pointing to 5, 5 is pointing to 6 and 6 is pointing to null. Since there is nothing is present, we understand that 6 is pointing to null. So when we will traverse and when the head is in null, here the pointer is in 6 and when we go to the next, then this will be a null. That means it terminates. This list doesn't terminate. Okay, there is no null. There is a cycle that keeps on going. Okay. So this is false. It doesn't have a cycle. So how do we solve this problem? How do we determine that there is a cycle in the linked list? Okay. So when we traverse the linked list, we start traversing the list. So the list could be very big. So when the list doesn't come to an end, the list could be very big. Okay. So even if, so how we will determine? If we store the numbers can be repeated. If we store the pointer, okay, if we take a map and we store the pointer, okay, this pointer is there in the map, whatever is the address is there, this is present, this is present, this is present, and then again this is present. Okay, when we see, okay, in this map this pointer is already present, then we will be able to know, okay, so this has repeated. If there is a repetition of the path, right, and since it's a single linked list, we'll understand that, okay, there is a cycle. So this is one way that we can have a map and we can store the address of the linked list or the and in the map, and if it repeats, so we come to know that there is a cycle. But the problem is that though we are traversing it in a single traversal, the time complexity order but we have taken extra space. So how can we avoid that extra order and space? So we know how we found the middle element of the linked list. We use the tortoise and hare algorithm, right? We had a slow pointer which does one step traversal, and we had a fast pointer which does for 2-step traversal. So with this algorithm, we were able to find the middle element, right? Can that help us to find the cycle? So in that algorithm, the fast was pointing to null at one point. So that was our termination point, that if fast points to null and the fast next, if that points to null. If you don't know what is the tortoise and hare algorithm, please see the first question of the linked list, okay, where we have discussed how to find the middle element of the linked list. Okay, so in that algorithm, tortoise and hare algorithm, the fast was pointing to null, right, at the end. But if there is a cycle at that point, fast will never point to null, right? It would keep on repeating. So let's take this example. If this is a slow and this is we don't need slow, right? We can have the same pointer head because we are not going to go back and return the linked list. We just need to return whether it is a cycle or not. So let's keep it as state. Why to take extra one variable pointer space? Okay. So we take just the fast, and this fast moves 2 steps. It comes at 2 and the head is at 1, and this fast goes to 2 steps. So 2 from 2 it goes to 3 and then it goes to 1, right? But the head has moved to 2, right? Now when head moves to 3, then fast moves to 2 and 3. So at this point we see that fast and head has become same. So you can try every example, since whenever there is an algorithm also which proves that if there is a cycle and we have this fast and the slow moving or fast moving twice and slow moving for one step, at one point they will meet. And if they meet, that means there is a cycle. Because if there was no cycle, they would have never met, because the fast would have come to the end, right? Fast would have ended. But since it's not, fast is not ending, fast is not coming to null and it's repeating. So at one point, both of them will be at the same point, and that would be our termination condition. You'll understand that it is a cycle. So let's code it as simple as that. List node strict fast is equal to head. Okay. So while head not equal to null and fast not equal to null and fast next not equal to null, right? We move head is equal to head next, fast is equal to fast next the next. If head equal to fast, both are same, then we return 1, or true. If it doesn't happen, then it will terminate at one point, like here 4 to 6, and 6 next is fast next is null, so it will terminate. And if it terminates, that means return false, 0. Okay, I think it's clear. The link to the question is given in the description. Please try it yourself and then come to my code walkthrough section. The code walkthrough of the 81st question, linked list cycle, in the LeetCode platform. The companies that have asked these questions, you can see them. Recently it has been asked in Google, Amazon, Microsoft, and in Oracle within these 6 months. So you can see we need to solve it in order of one space. Okay, that's why we have this tortoise and hare algorithm, slow and fast. So when we see that this, we don't need slow here, because we don't need to, as I've discussed, go back to the point. We just need to return whether it is a cycle, it has a cycle or not. So we move head is equal to head next, fast is equal to fast next, and if head is equal to fast, then we return 1 as discussed. It contains cycle, otherwise it doesn't contain cycle, we return 0. So we'll directly submit this code. So it has passed. Okay, so see you all soon in the next video, where I'll be explaining the 82nd question of the problem solving series, which is actually a extension of this problem, where we need to detect the starting point of the linked list. So please check the next video. Jai Jinendra.